Hello, greetings class. Here we have just some supplementary notes that I mentioned I was going to give you guys to deal with the intake manifold designs and how it affects power delivery at different RPM ranges. So here we're dealing with a single plenum intake, but first let's remember some facts. So the intake stroke of the engine creates a decrease in pressure within the intake manifold. Atmospheric pressure, which is at 14.7 psi, pushes air into the intake. And this area here will be, let's just say, less than 14.7 psi. Only then will air actually be able to travel into the intake plenum, because higher pressure will always try to balance out a lower pressure area. Okay, here are some notes. So this is an intake single plenum. A single plenum intake manifold has one opening that delivers air to each cylinder. The larger the plenum volume area provides less restrictive flow and a greater supply of ready-to-use air from each cylinder at high RPM ranges. Okay, so we're going to analyze this diagram here now. Figure A. Okay, Figure A is this dotted imaginary line that I've drawn here on the intake picture here. So this line represents the division between air that is outside the intake plenum, which is at 14.7 psi. And this also includes components such as intake air hoses, your air box, your fresh air inlet, and obviously the atmosphere, the air outside. This air hasn't been pushed into the plenum area yet. Below the line, well, technically below the throttle plate, so below the line, okay, below the line is the air that is already inside the plenum, and it exists there in conditions less than 14.7 psi. Okay. B in the single plenum intake, B is the plenum area. The plenum, remember the definition, plenum is what serves as a reservoir of air that is used by each runner to draw into each cylinder. So in a single plenum type intake, the plenum area is much larger than a dual plenum intake. Due to the larger space of a single plenum interior, it takes longer for the intake stroke of the piston to create a decrease in pressure, and it also requires a greater number of intake strokes to decrease the pressure inside the plenum. This way, outside air, which is greater, will begin to push air inside the intake. So compared to a dual plenum intake, which has a smaller chamber, which I will get into, it just requires more time and more effort for the cylinders to actually start creating a decrease in pressure in this area. And only when only then will air actually start to be pushed into the engine from atmospheric pressure. So that's why on a single plenum type intake, these intakes are more effective at higher RPM ranges. When the number of intake strokes, obviously it will increase with RPM increases, right? And also because of the increase, you're actually going to be creating only then will you be creating an area here with less than 14.7 psi.